Hello, in this lecture you'll find out the area of the orange shape using two different methods. In the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles that intersect with each other at 90 degrees. We have semicircle CPD and the other semicircle is semicircle APD, and they intersect with each other at point P. And we also have quarter circle ABDQ that is also inside the square, and our mission is to find out the area of this orange shape. Okay, so we start with the first method. In the first method we will find out the area of the big lens. Here, when two circles intersect with each other, they create a common area, and the common area that is between the two circles or semicircles is defined as a lens. So we find out the big lens. This is the big lens, and we subtract from the big lens the area of the blue lens. And in this way, if you subtract from the area of the big lens, this is the big lens, if you subtract from the area of the big lens the area of the blue lens, you will get the area of the orange shape. That is what we want to find out in this question. Okay, I'll repeat again that we'll find out the area of the big lens, and we subtract from the area of the big lens the area of the blue lens. In this way we get the area of the orange shape, that is actually shape DPQ. Okay, but first of all I will explain to you what is the area of a sector. This is a sector. The green area is a sector, that is a part of a circle, and the area of this sector, it is equal to the area to theta over 2 pi times the area of the circle, that is pi r square. Again, theta over 2 pi times pi r square equals to area of this sector, the green sector. And also the area of a circular segment, the green circular segment, it is equal to the area of sector AOB, the area of this sector AOB. This is the area of the sector AOB minus the area of triangle AOB. If you subtract the area of triangle AOB from the area of sector AOB, we will get exactly the area of the green circular segment. Again, so the area of the green circular segment equals to the area of sector AOB, the area of this sector, minus the area of triangle AOB. Okay, so here we have two semicircles that intersect with each other, and they create this lens. Actually, in the intersection point, they create a common area, and the common area is defined as a lens. So we'll find out the area of this lens, and then we'll use the general formula that we created here in order to find out the area of the big lens, and we also find out the area of the blue lens by using the general formula that we will create for the area of this lens. Okay, so here we define the radius of this semicircle as A, and we define the radius of this semicircle as B. So here the radius is, we will define the center of this circle as O, and here we'll define the vertex here as N. So here we have the radius ON, that is A. It is drawn to point N, that is the point of tendency of tangent LN with this semicircle. So, and whenever you have a radius that is drawn to the point of tendency, it means that tangent LN will be perpendicular to the radius ON. If LN is perpendicular to NO, it means that this angle equals to 90 degrees. So here we have, this is also the radius from the center of the semicircle. We have here the radius, so the radius that is equal to A. So the radius here is it is drawn to the point of tendency, the radius OM of this semicircle, it is drawn to the point of tendency of tangent LM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent LM will be perpendicular to the radius OM. So if LM is perpendicular to OM, it means that this angle equals to 90 degrees. This is according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Okay, so here we will join points N and M together by a straight line. And the area of the lens consists two circular segments. Okay, so this is the first circular segment that this length consists of, and the area of this circular segment it is actually equals to so this is circular segment NM, the green circular segment. It will be equal to, according to the formula that I presented to you, it will be equal to the area of sector NOM, the area of this sector, minus the area of triangle NON. Minus the area of triangle NOM. So here we will join points O and L together by a straight line. We will define angle NOL as theta. So here point L is the center of this semicircle, and point M is the point of the semicircle itself. This is exactly the definition of a radius. That is to say, LB is the radius of this semicircle that is equal to B according to our definition. Okay? So here triangle NDL, this triangle is congruent to triangle DLM. I write it down. Triangle NOL and triangle LON. We'll focus on those two triangles and we'll prove that those two triangles can go into each other. So why those two triangles can go into each other? First of all, NO equals to OM equals to A. It is the radius of this semicircle. NO equals to OM. It is the radius of this semicircle that is equal to A. In addition, we have NB, NL that is equal to B. It is the radius of this semicircle. NL is equal to LM. This is LM, and both those two sides are equal to B. They are the radii of this semicircle. And we also have a common side. OL is a common side that belongs to both triangles. So LO equals to itself. LO equals to itself. It's a common side that belongs to both triangles. We actually proved that those two triangles can relate to each other according to side rule. So triangle NOL can relate to triangle LOM according to side rule. And from the fact that those two triangles can relate to each other, we'll conclude that those two angles are equal to each other. That is to say, angle NOL is equal to this angle that is actually angle LOM. And angle LOM equals to theta according to our definition. So angle LOM equals to theta. So from this equation, theta equals to angle LOM equals to angle LOM, we'll derive that angle LOM also equals to theta. So this angle equals to theta. So here, triangle ONL, this is a right triangle. In this right triangle, this angle equals to theta, this angle equals to 90 degrees, that is, in terms of radians, it is pi over 2. Therefore, the missing third angle must be equal to 90 degrees minus theta, that is, in terms of radians, is pi over 2 minus theta. 90 degrees minus theta in terms of degrees equals to pi over 2 minus theta in terms of radians. Okay. Actually, those two angles are equal to each other because those two triangles are equal to each other. And in addition, this angle equals to theta, this angle equals to 90 degrees minus theta, therefore this angle must be equal to pi over 2 minus theta, that is 90 degrees minus theta in terms of radians. So actually, angle NOM, this angle equals to 2 theta, and this angle NLM, it is equal to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, this angle equals to pi minus 2 theta. Okay. And here tangent theta equals to, in triangle ONL, tangent theta equals to B over A. tangent theta equals to B over A, it means that if we operate the opposite function of tangents on the result, that is B over A, if we operate the opposite function of tangents, that is tangents minus 1, on the result, that is B over A, we'll get theta. Okay, so in conclusion, we found out that tangents minus 1 of B over A equals to theta. And here the area of the lower circular segment the area of the orange circular segment of the orange circular segment NM will be equal to the area of sector NLM. This is sector NLM This is sector NLM minus the area of triangle NML. Side NL equals to B units and side LM also equals to B units. This is the area of sector circular segment NM, when the area of circular segment NM equals to the area of sector NOM minus the area of triangle NOM. This is triangle NOM. That is to say, side NO equals to A units, side OM also equals to A units. So actually the area of this lens that composed of two circular segments, it is equal to the sum of the areas of this circular segment plus the area of this circular segment. So here we can write down that the area of the lens, it will be equal to the area of the, in total, the area of the lens. This is the lens that we are looking for, is composed of two circular segments. So it will be equal to the area of this circular segment that is equal to the area of the two sectors minus the area of the two triangles. So it will be actually equals to the area of this sector plus the area of this sector will be equal to the area of the two sectors this is sector NML plus the area of sector ONM this is sector NOM minus the area of those two triangles. Okay. So here we'll combine the two triangles together, we'll join the two triangles together, and in this way we will get quadrilateral NOML side OM equals to A, side MN also equals to A, side NL equals to B, and side LM equals to B. Here we'll join points O and L together by a straight line. So we added the two triangles together, and we have this quadrilateral NLOM. So actually the area of the green right triangle equals to A times B over 2, and the area of the orange triangle, orange right triangle, equals to A times B over 2. So A times B over 2 plus A times B over 2 equals to A times B. In conclusion, we found out that the sum of the areas of those two triangles equals to AB. So we have to subtract from the area, from the sum of the areas of those two sectors, AB, that is the area of the two right triangles. Okay? So here we find out the area of sector N and M. Or first of all, we find out the area of sector NOM. The area of sector NOM of sector NOM the area of this sector. Here we know that the angle between his legs is theta plus theta is 2 theta. Here NO equals to A and OM also equals to A. So the area of sector NOM will be equal to 2 theta over 2 pi times pi r squared times pi r squared. R equals to A, so it is times pi a squared. So in conclusion, I found out that the area of sector NOM is equal to, we have pi in the numerator and pi in the denominator, so pi over pi is 1, so it gets cancelled. 2 over 2 is also 1, so it also gets cancelled. So in conclusion, I found out that the area of sector NOM, the area of this sector, equals to theta times a squared. We repeat on the same process in order to find out the area of sector N and M. The length of N is B, it is the radius of the semicircle, and the length of NM also B. And the angle, this angle NLM equals to pi minus 2 theta. Okay, this angle equals to pi minus 2 theta. So I write it down that this angle equals to pi minus 2 theta. This is sector NLM. So the area of sector NLM will be equal to pi minus 2 theta over 2 pi times pi r squared. Here r equals to b, so it is pi b squared. Pi b squared. So here we have pi in the numerator and pi in the denominator, so it will get cancelled. We'll open the brackets here and we'll get that pi b squared over 2 and here we have minus 2 theta b squared over 2. So in conclusion, the area of this sector equals to pi b squared over 2 minus 2 over 2 is 1, so it will get 2 will get cancelled, minus theta b squared. Okay. So actually the area of the lens, as I already said, the area of the lens is the sum of the areas of the two circular segments. The green circular segment plus the orange circular segment, it is the area of this lens. So we will have to add the areas of the two sectors with each other minus the area of the two triangles. Okay, so the area of the lens of this lens, it is equal to the area of circular segment, the orange circular segment, that is equal to theta times a squared plus the area of the other sector that is actually here, the area of this, it is, I found out that it is equals to pi b squared over 2 minus theta b squared. So this expression is the sum of the areas of the two sectors, and we have to subtract from the area of the sum of the areas of the two sectors, the area of the sum of the areas of the two triangles, that is AB. So it is minus AB. So the area of this lens equals to theta times a squared plus pi b squared over 2 minus theta b squared minus AB. So here we take theta as a common factor. So what is left of this expression after we took from it theta as a common factor? What is left is actually a square. And what is left from this expression after we took from it theta as a current factor? What is left? It is actually b squared. And here we also add, we have to add pi b squared pi b squared over 2 minus ab. So that is the area of the lens equals to pi times a squared minus b squared plus pi b squared over 2 minus a. We have already found out that theta equals to tangents minus 1 times b over a, so we can substitute theta by tangents minus 1, that is the opposite function of tangents, times b over a. We'll do it now and we'll get here that the area of the lens is actually equals to a squared minus b squared times theta, and theta equals to tangents minus 1 of b over a, and we have to add also pi b squared over 2 minus ab. Okay, we actually found here a general formula that will help us to find out the area of any lens. And I already explained to you that the area of the blue, of the orange shape equals to the area of the big lens minus the area of the blue shape. Also the area of the big lens minus the area of the blue lens give us exactly the area of the orange shape, that is dpq, that is the area that we are looking for. So in order to find out the area of the big lens that consists the area of the blue lens plus the area of this shape, in order to find out the area of this big lens, we will put the data inside this formula for the area of any lens, and we'll get the area of this big lens. So here A equals to 10, because A is the radius of the quarter circle, that is equal to 10 units. You can see from the drawing that the radius of the quarter circle equals to 10, therefore A equals to 10 units. And the radius of the semicircle equals to 5 units. So if the center of this semicircle is at this point and side DC equals to 10 units, it means that the radius is half of it. So the radius of the semicircle equals to 5 units. So here B equals to 5. So we'll put the data, the value of A and B, inside this general formula in order to find out the area of the big lens. So the area of the big lens will be equal to A is 10, so A square is 10 square, minus b. B equals to 5 units, so b squared is 5 square times tangents minus 1. B is 5 and A is 10, so 5 over 10 is 0.5. 0.5 plus pi. B is 5, so b squared is 5 square, that is 25 over 2 minus AB. A is 10 as b is, and b is 5, so it is 5 times 10. So in conclusion, we found out that the area of the big lens it is equal to 10 square is 100 minus 5 square is 25. 100 minus 25 is 75. So it is actually equals to 75 times tangents minus 1 of 0.5. That is the opposite function of tangents. Plus pi 25 over 2. 25 over 2 is 12.5. So here this expression equals to 12.5 pi plus 12.5 pi minus 5 times 10 is minus 50. So we found out the area of the big lens. In the next step, we'll find out the area of the blue lens, and when we subtract from the area of the big lens the area of the blue lens, we get exactly the area of the orange shape, that is dpq. Okay, now we calculate the area of the blue lens. The area of the blue lens it is here. We know that this blue lens was created by the intersection of the two semicircles with each other, and the radius of each semicircle equals to 5 units. So here A equals to 5 and B is also equals to 5 units. So we put the data inside the general formula and we find out the area of the blue lens. This is the formula for the area of any lens. So here A equals to B equals to 5 units. So A square is 5 square minus B square, that is also 5 square, times tangents minus 1 of B over A. B over A is 5 over 5, that is 1. Plus pi B square. B is 5, so B square is 5 square, that is 25. And here it is pi times 25 over 2 minus AB. A is 5, B is 5, so A times B is 5 times 5, that is 25, so it is minus 25. So in conclusion, I found out that the area of the big lens, the area of the blue lens, the area of the blue lens equals to this expression equals to 0, because 5 squared minus 5 squared is 0, and 0 times anything is 0. So this expression equals to 0, plus 25 over 2 is 12.5 pi minus 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. Okay. Now we will subtract from the area of the big lens the area of the blue lens. In this way we get the area of the orange shape, dpq. So the area of the orange shape, that is equals to dpq, the area of the orange shape is dpq. This is the orange shape, and the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so we'll subtract the area of the big lens. We'll subtract the area of the blue lens from the area of the big lens, and we'll get the area of the orange shape. So it is actually equals to the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. This is the area of the big lens minus the area of the blue lens, that is equals to 12.5 pi minus 25. So here we'll open the brackets and we'll get that 75 times tangents minus 1 of 0.5 plus 12.5 minus 50 minus, it is plus 12.5 pi of course, minus 12.5 pi, minus is plus, so it is minus plus 25. Okay, so here we have 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled, and we have here 25 minus 50 is minus 25. So in conclusion, we found out that the area of the orange shape dpq equals to 75 times tangents minus 1 of 0.5. So it is 75 times tangents minus 1 of 0.5 minus 25 square units. This is the area of the orange shape dpq. So we find out the value of tangents minus 1 of 0.5. It is about tangents minus 1 of 0.5 is about 0.46. So we'll multiply 0.46 by 75, the result is 34.77 minus 25. 34.77 minus 25 equals to 9.77 square units. Okay, so we actually found out that the area of the orange shape, according to the first method, equals to 9.77 square units. That is the area of this blue shape that is actually defined as dpq. It is equal to 9.77 square units. We finished with the first method. In the next step I will present to you how to find out the area of this orange shape according to the second method. Okay. So in the second method, we'll actually use the same method. Here we have to subtract the area of the blue lens from the area of the big lens. The area of the big lens minus the area of the blue lens will give us the area of the orange shape. Okay? So, first of all, we have to find out the area of the blue lens, of course. But here, so this is the blue lens. And here, we have already found out in the first method, according to the rule that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent NM, or the radius ON is drawn to the point of tendency. Therefore, this angle will be equal to 90 degrees, because whenever you have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. For that reason, this angle equals to 90 degrees. Okay, and here also, this is the radius, and M is the radius of this semicircle, and in here A is the radius of this semicircle. This is the center of this semicircle. Point O is the center of the semicircle. Point L is the point of the semicircle itself. This is exactly the definition of a radius. That is to say, OL is the radius of this semicircle that is equal to A units. So here we have the radius OL that is drawn here. This is the center point M is the center of this semicircle. So we have the radius OL that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent ML with this semicircle. And whenever we have a radius that is drawn to the point of tendency, tangent ML will be perpendicular to the radius OL. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. Okay? In the next step, we'll join the 2 points O and M together. Here we'll define this angle as theta. We have already proved here point M is the center of this semicircle, point L is the point on the semicircle itself, ML is the radius of this semicircle, that is equal to B units. In the first method, we have already proved that those two right triangles can go into each other. So if this angle equals to theta, this angle must be also equal to theta. And we have already proved that this angle equals to pi over 2 minus theta. And this angle also equals to pi over 2 minus theta. So in total, this angle NML equals to pi minus 2 theta. We have already proved it in the first method. And this angle equals to 2 theta. So here we'll join points N and L together by a straight line. So we will find out, we have to find out the area of the blue lens. This is the blue lens, and we want to find out the area of the blue lens. The area of the blue lens equals to the area of the green circular segments times 2. Why? Because those two parts, they are symmetric to each other. That is to say, those two circular segments, they are equal to each other in their areas. So if we multiply the area of the green circular segment NL by 2, we'll get the area of this lens. That is the area of the blue lens, of course. Okay? So, but here we know that the radius of each semicircle equals to 5 units. So this is equal to 5, equals to 5, B equals to 5. So the area of the green circular segment it is equal to the area of sector NOM we know that OM equals to 5 units and O also equals to 5 units. And then get NON is actually sector NON this angle equals to 2 theta minus the area of triangle NON. Okay, this is triangle NON. So here the area of sector NON, it is equal to 2 theta over 2 pi times. So here we don't have to calculate at all the area of this sector because this sector is a quarter circle. And because of the fact that NOL is a quarter circle, the area of any quarter circle is the area of the circle over 4. So here we know that the area, that the radius of this quarter circle equals to 5 units. Therefore, the area of this circle will be equal to pi r square, and r equals to 5. So it is actually pi times 5 square. This is the area of the circle, and we have to divide it by 4 in order to find out the area of the quarter circle. So this is the area of this quarter circle. That is to say, this quarter circle, it is actually sector NON. So the area of sector NON equals to the area of the quarter circle NON, that is pi square over 4 minus the area of triangle NON. And the area of triangle NON, here NO equals to 5 units. And N equals to 5 units. So because of the fact that this angle, this is a quarter circle, it means that this angle equals to 90 degrees. That is to say, it means that theta plus theta equals to 90 degrees. So this is a right triangle. And the area of right triangle NON will be equal to the base of the triangle times the height to the base over 2. That is to say, it is 5 times 5 over 2. In conclusion, we found out that the area of the orange circular segment, the area of the green circular segment equals to 5 squared is 25 times pi over 4. Okay, but we know we want to find out the area of length of this length that is twice as big as the area of the circular segment. So in order to find out the area of the length, that is actually the area of the blue length, this is the area of the blue length, we have to multiply the area of the green circular segment by 2. So here we multiply this area by 2, and we get that the area of the blue length, it is twice as large of the area of the green circular segment. So it will be equal to 2 times 5 squared is 25, so it is 2 times 25 pi over 4 minus, we have here 25 over 2, so 25 over 2 times 2 is 25. So in conclusion, we actually found out that the area of the blue lens, here we'll divide both the numerator and the denominator of this expression by 2, and we'll get, so here 2 will get cancelled, and 4 over 2 is 2. Okay, and 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi minus 25. In conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. Okay, so actually we finished with the first step. In the first step, we found the area of the blue lens, and the area of the blue lens equals to 12.5 pi minus 25 square units. In the next step, we'll find out the area of the big lens, and then we'll subtract from the area of the big lens the area of the blue lens. In this way, we'll get the area of the orange shape. Okay, so the next step is to find out the area of the big lens. Okay, so our mission here was to find out the area of this big lens. Okay, so I write it down. So we'll find the area of the big lens. Okay, so here we know that one side of square ABCD equals to 10 units, so this equals to 10. This will be point O, and we'll join those 2 points together. This point will be L. Here, the radius of the semicircle equals to 5 units. Here, we'll know the radius here. It will be tangent to the quarter circle at this point. Okay, so point L is the center of the semicircle. Point M is a point on the semicircle itself. Therefore, this is the radius of the semicircle, that is equal to 5 units. We join points O and M together by a straight line. Point O is the center of the quarter circle. Point M is the point on the quarter circle itself. This is exactly the definition of a radius, that is to say OM equals to 10 units. Okay. So here we'll join points N and M together by a straight line. We'll find out the area of the big lens in 2 steps. First of all, we'll find out the upper circular segments, and in the next step we'll find out the lower circular segments. So in the first step we'll find out the upper circular segment. That is to say, the green shape. The upper circular segment is the green shape NM. Okay. So here, if we define angle NOL as theta, those 2 triangles can go into each other according to side rule. Side NO equals to side OM equals to 10 units. Side NL equals to side LM equals to 5 units. And we have also a common side OL, so that is equal to itself. So those 2 triangles can go into each other according to side rule. So if this angle equals to theta, it means that this angle must be also equal to theta, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? So what is the area of the green circular segment, NM? What is the area of the green circular segment? The area of the green circular segment NM for the drawings is very easy to see, and according to the formula that I presented to you, that is equal to the area of sector NOM. This is the area of sector NOM This is sector NOM. This angle equals to 2 theta. Minus the area of triangle NOM. Okay, it is very easy to see from the drawing that if you subtract from sector NOM the area of triangle NOM, you will get exactly the area of circular segment NM, the green area. Okay. So the angle between the legs of sector NOM equals to 2 theta, and 2 theta is also the angle between the sides of triangle NOM. So the area of the upper circular segment of the big length NM the area of this green circular segment is actually equals to the area of sector NOM. The angle between the legs of the sector NOM is they are equal to, it is equal to 2 theta, and the area of any sector is 2 theta over 2 pi times the area of the circle. Here, the radius of the quarter circle is 10, so this is 10, this is 10, this is 10, and this is 10. So pi r square, r equals to 10, so it is pi times 10 square. This is the area of sector NOM minus the area of triangle NOM. Note that the area of any triangle equals to the multiplication of the two sides by each other times the angle between those two sides over the multiplication of the two sides by each other times sinus the angle between the two sides over 2. So the area of triangle NOM will be equal to 10 times 10 times sinus 2 theta over 2. Okay. So this expression equals to the area of the green circular segment NM. Okay. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator, 2 in the denominator, 2 will get cancelled also. So in conclusion, this expression equals to theta, or 10 square is 100, so it is 100 times theta minus 100, 10 times 10 is 100, and 100 over 2 is 50, so it is 50 times sinus to theta. Okay. So here we draw the right triangle NLO here. This is the right triangle NOL. This angle equals to 90 degrees. Because the semicircle is perpendicular to the quarter circle. Anyway, you have here this quarter circle. This is the quarter circle, and here LN, tangent LN is here the radius ON of the quarter circle is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent LN with this quarter circle, and whenever you have a radius that is drawn to the point of tendency, then tangent LN will be perpendicular to the radius NO. That is to say, if LN is perpendicular to NO, it means that this angle equals to 90 degrees. LN is perpendicular to NO, that is to say that this angle equals to 90 degrees. Okay? So, angle ONN equals to 90 degrees. This angle equals to theta according to our definition. NN is the radius of the quarter circle that is equal to 5 units. NL is the radius of the semicircle that is equal to 5 units, while NO is the radius of the quarter circle that is equal to 10 units according to what is given as the question. So if we focus on the right triangle NON, then it is very easy to see that tangent theta equals to NL over NO. NL equals to 5, NO equals to 10, 5 over 10 is 0.5. In conclusion, we found out that tangent theta equals to 0.5. And what is the value of theta? If we want to find out the value of theta itself, we have to operate the opposite function of tangents on the result, and we'll get the theta itself. So the opposite function of tangents is tangents minus 1. We'll operate it on the result, that is 0.5. In this way we'll get the value of angle theta, or the size of angle theta. The size of angle theta in terms of radians and not degrees, because here we are using only radians and not degrees. So actually we found out that tangents minus 1 of 0.5 equals to theta. So here I will draw the right triangle again. This is the right triangle NOL. Side NO equals to 10 units. Angle NOL equals to theta according to our definition. Side NL or LN equals to 5 units. Angle NOL, angle ONL equals to 90 degrees. So here, if we implement the Pythagoras theorem on this right triangle LON, we will get that the hypotenuse LO square, the square of the hypotenuse, equals to the sum of the square of the perpendiculars. That is to say, LO square equals to 5 squared, that is 25, plus 10 squared, that is 100. So LO square equals to 100 plus 25 is 125. We take a root out of this equation and we get that the hypotenuse LO equals to the square root of 125. But 125 is 25 times 5. So we substitute 125 by 25 times 5 and we get that the square root of 25 is 5. Inside the root we left only with 5. So in conclusion, we found out that the hypotenuse LO of the right triangle LON equals to 5 times square root of 5 units. Okay? And we actually have the trigonometric identity that states that sinus 2 theta equals to 2 times sinus theta times cosine theta. That is to say, sine 2 theta equals to 2 times. And what is the value of sinus theta? From this drawing, it is very easy to see that sinus theta equals to 5 over 5 times square root of 5. ln over no, ln over no equals to 5 over 5 times square root of 5. That is the value of sinus theta, while cosine theta, from this triangle you can see that cosine theta equals to NO over LO. NO over LO equals to 10 over 5 times square root of 5. Okay? So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in the numerator we left only with 10, 2 times 10 over square root of 5 times square root of 5 is 5 times 5. So here is equal to 10 over 5 is 2, so it is 2 times 2 over 5. 2 times 2 is 4 over 5. So in conclusion, we found out that sinus 2 theta equals to 4/5. So I write it here. In conclusion, I found out that sinus 2 theta equals to 4/5. While tangent theta of -1 of 0.5, tangent -1 of 0.5 equals to theta, or theta equals to tangent -1 of 0.5, that is the opposite function of tangents, that we operate this function on 0.5, and the result should be theta. So now we already found out that the area of circular segment NM, the area of this circular segment, that is actually the upper side of the big lens, it is equal to 100 times theta minus 50 times sinus 2 theta. Okay, now we substitute theta by tangent -1 of 0.5, and we substitute sinus 2 theta by 4/5. So we'll do it now, and we'll get that 100 times theta is 100 times tangent -1 of 0.5 minus 50 times 2 theta, and 2 minus 50 times sinus 2 theta, and we already found out that sinus 2 theta equals to 4/5. Okay, so here in conclusion, we found out that the area of the upper circular segment, that is the area of this green shape, the area of the green circular segment, equals to 100 times tangent -1 of 0.5. Here, what is the value of this expression? 50 over 5 is 10, and 10 times 4 is 40. So in conclusion, this expression equals to -40. And in conclusion, we found out that the area of the upper side of the big lens equals to 100 times tangent -1 of 0.5 minus 40. In the next step, we find out the lower side, the area of the lower side of the big lens. That is to say, we find out the area of this circular segment. Okay, so we have here I will repeat again, our mission is to find out the area of the lower circular segment that I paint in the green color. The area of this circular segment if you focus on the right triangle ONL, angle LON equals to theta. Angle ONL, this angle equals to 90 degrees. In terms of radians, 90 degrees is pi over 2 radians. So the missing angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this right triangle to 180 degrees, this angle must be equal to pi over 2 minus theta. Here we have this radius OM is the radius of the quarter circle that is equal to 10 units. This radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is a point of tendency of tangent LM with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent LM must be perpendicular to the radius MO. So if LM is perpendicular to MO, it means that this angle equals to 90 degrees. This is a right angle. So here, angle LOM equals to theta, angle LMO equals to 90 degrees, that is in terms of radians is pi over 2. Therefore, the missing angle must be equal to pi over 2 minus theta. So what is the size of angle NLM? The size of angle NLM, it is the sum of those two angles, that is pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle NLM, the size of this angle, it is actually equals to pi minus 2 theta. Okay, this angle equals to pi minus 2 theta. So what is the area of the green circular segment NM? According to the formula that I presented to you, the area of the green circular segment NM will be equal to the area of this circular segment NM. Actually, the area of any circular segment, if you relate to a circle, will be always the area of the sector that contains the circular segment minus the area of the triangle that actually it is part of the circle of the sector. Okay, so the area of this circular segment NM will be equal to the area of sector NOM, that is to say the area of this sector NOM this is sector NLM minus the area of triangle NLM, minus the area of triangle NLM, we have already found out that this angle NLM is equal to pi minus 2 theta. This angle NLM equals to pi minus 2 theta. So therefore the area of sector NLM of sector NLM it is equal to the angle between the legs of the sector, that is pi minus 2 theta over 2 pi, that is 360 degrees in terms of radians, times the area of the circle, that is here Lm equals to 5 and L equals to 5. This is 5 and this is 5. So the radius of the semicircle equals to 5. Therefore pi r squared is pi 5 r equals to 5, so it is pi times 5 squared. So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. We have pi in the numerator and pi in the denominator, so pi will get cancelled. And we have to subtract from the area of sector NLM the area of triangle NLM. The area of any triangle equals to the multiplication of the sides of the triangle by each other, that is 5 times 5, 5 times 5, times sinus the angle between the two sides, that is sine pi minus 2 theta, divided by 2. Okay? So here we have pi minus 2 theta over 2. So here we'll open the brackets on this expression and we get that this is pi over 2, 5 squared is 25, minus 2 theta over 2 times 5 squared is 25, minus 5 times 5 is 25, sinus pi minus 2 theta equals to sinus 2 theta, according to the trigonometric identity that sinus, exactly this is the trigonometric identity that sinus pi minus 2 theta equals to sinus 2 theta. Okay, all divided by 2 of course. So here 25 over 2 is 12.5, 12.5 pi, 2 over 2 is 1, so 2 will get cancelled. So it is minus 25 theta. Here we have minus 25 over 2, and we already found out that sinus theta equals to 4/5. So we substitute sinus 2 theta by 4/5, and we'll get here that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 times theta, and we have already found out that theta equals to tangents minus 1 of 0.5, so we substitute theta by tangents minus 1 of 0.5 minus here this expression 25 over 5 is 5, and 5 times 4 is 20, is 20 over 2 is 10. Okay? In conclusion, this expression in total equals to minus 10. Okay? So the area of the lower circular segment of the big lens, the area of this circular segment, NM, in conclusion, it is equal to 12.5 pi minus 25 times minus 1, 0.5 minus 10. Now we will add the upper circular segment to the lower circular segment. In this way we will get the area of the total area of the big lens. I repeat again that the total area of the big lens composed of the upper circular segment and the lower circular segment. So if we add the upper circular segment to the area of the upper circular segment to the area of the lower circular segment, here, if we add those two areas together, we'll get the area of the big lens. I repeat again that the area of the big lens of this big lens it consists two circular segment, upper circular segment and lower circular segment. This is the big lens, and the sum of the two areas, the area of the upper circular segment plus the area of the lower circular segment, will give us the area of the big lens. Okay? This is the area of the big lens. Okay? We have already found out that the area of the upper circular segment equals to 100 times tangents minus 1 of 0.5 minus 40. This is the area of the upper circular segment, and we just right now found out that the area of the lower circular segment equals to 12.5 pi minus 25 tangents minus 1 of 0.5 minus 10. Okay? So here we have 100 tangents minus 1 of 0.5 minus 25 times minus 1 of 0.5 equals to 75 times minus 1 of 0.5. Okay, minus 40 plus minus 10 is minus 50 plus 12.5 pi. So this is the area of the big lens. Okay, the area of the big lens equals to 75 times minus 1 of 0.5 minus 50 plus 12.5 pi. Now we'll subtract from the area of the big lens the area of the blue lens, and we have already found out that the area of the blue lens equals to the area of the blue lens equals to 12.5 pi the area of the blue lens equals to 12.5 pi minus 25. So we'll subtract from the area of the big lens to the area of the blue lens, and we'll get here that the result is the area of the orange shape DPQ, the area that we are looking for. So the area of the blue shape DPQ, now this orange shape actually, DPQ, now the orange shape, now this orange shape will be equal to 75 times minus 1 of 0.5 minus 50 plus 12.5 pi, and we have to subtract minus 12.5 pi, and here we have minus and minus is plus, so it is plus 25. So here 12.5 pi minus 12.5 pi is 0, so it will get cancelled. And minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape PDQ is equal to 75 times minus 1 of 0.5 minus 25. Okay, and the value of tangents minus 1 of 0.5 equals to about 0.46. So 75 times 0.46 minus 25, it is actually equals to 75 times 0.46 equals to 34.77 minus 25, 34.77 minus 25 is 9.77 square units. So in both methods we arrive to the same result. That is to say, the area of this orange shape PDQ equals to 9.77 square units. Okay, we finished the second method. In the next step I will summarize the lecture. We'll start with the first method, of course. So in the drawing we have square ABCD. Inside square, we know that one side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles that intersect with each other at 90 degrees. The first semicircle is CPD, the semicircle, and the second semicircle is DPAPD. The two semicircles intersect with each other at 90 degrees and they create the blue lens. And inside the semicircle we have square quarter circle A, B, Q, D, and this quarter circle intersects with this semicircle, and in this way it creates the big lens, this big lens. Okay, so in the intersection of the two semicircles together creates the blue lens, while the intersection of the semicircle with the quarter circle creates the big lens that consists of the blue lens plus the orange shape. And our mission is to find out the area of the orange shape QPD. It is very easy to see that the area of the big lens minus the area of the blue lens will give us exactly the area that we are looking for, that is to say the area of the orange shape PQD. Okay, so in both methods we used the same idea, that we will subtract the area of the big lens minus the area of the blue lens, give us exactly the area of the orange shape PQD. Okay, but before that I explain to you what is the area of a sector. The area of a sector, the green shape is the sector that we are looking for to find out the area of this sector. So the area of this sector, it is equal to the angle between the legs of the sector, that is theta, over 2 pi, that it is equal to 360 degrees, or 360 degrees is 2 pi in terms of radians, times the area of this circle, that is pi r squared. So the area of the circle that is pi r squared times theta over 2 pi is the area of this sector, the green sector. Okay, then I presented to you how to find out the area of this circular segment AB. The area of this circular segment it is very easy to see that the area of this circular segment AB, the green shape, equals to the area of sector AOB, the area of this sector, minus the area of triangle AOB. It is very easy to see that if you subtract from the area of sector AOB, if you subtract from this the area of sector AOB, the area of triangle AOB, we get exactly the area of the green circular segment AB. Again, the area of the circular segment AB equals to the area of sector AOB minus the area of triangle AOB, this triangle. Very simple. Okay, so actually in the first method we created the general formula to find out the area of any lens. So we actually don't know the dimension of the lens, and we created a general formula to find out the area of any lens, and then we calculated the area of the blue lens and the area of the big lens by using this general formula. Okay, so how we created the general formula for the area of any lens. So this is the lens that we are looking for. We have here those two semicircles intersect with each other at 90 degrees, and the intersection point, they create the common area, and the common area is the blue lens. This is the common area. This is not the blue lens, but this lens consists of the green color and the orange color. So the intersection of the two lenses give us this common area, and the common area is the lens that we are looking for. So how we will find out the area of this lens? So we divided this lens to two parts. The upper circular segment, that is the green circular segment, and the lower circular segment, that is the orange circular segment. And when we add the areas of the two circular segments together, we get exactly the area of this lens. Okay, so the area of the upper circular segment NM, it is equal to the area of sector NOM, the area of this sector, minus the area of triangle NOM. Again, the area of sector NOM minus the area of triangle NOM will give us exactly the area of the green circular segment, and then the area of the orange circular segment equals to the area of sector MLN, the area of this sector, minus the area of triangle LNM. This is this triangle. So then we will add the two angles together and we will get the area of this lens. Okay, again, this is, if we add the two angles together, we'll get the area of this lens. That is to say, the area of this lens will be equal to the sum of the areas of the two sectors MNO and LMN minus the area of those two triangles. Okay, so first of all, if we join the two triangles together, we'll create quadrilateral NLOM, and the quadrilateral NLOM, and then we will join points O and L together, and here we created two right triangles, and the area of the first right triangle is A times B over 2. The area of the second right orange triangle is A times B over 2. And the sum of the areas of the two triangles is A times B over 2 plus A times B over 2. A times B over 2 times plus A times B over 2 is A times B. So in conclusion, the area of those two triangles equals to A times B. That is to say, we have to subtract from the areas, for the sum of the areas of the two sectors, the area of the two triangles, that is A times B. Okay? So here, then we prove that triangle NOL, this triangle is congruent to triangle LOM. Those two triangles congruent to each other. Why they congruent to each other? First of all, we know that NO equals to OM equals to A. In addition, we know that NL equals to LM equals to B, and N equals to LM equals to B. The radii of this semicircle. And finally, we have LO is the common side that belongs to both triangles. So therefore, those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, it means that those two angles are equal to each other. So if this angle equals to theta, then from this equation, theta equals to angle NOM equals to angle NOM, we derive that this angle also equals to theta. Okay? Then, if we focus on the right triangle ONN, we know that tangent theta equals to B over A. Tangent theta equals to B over A. So, if we operate the opposite function of tangents on the result, it will give us the value of theta. So we'll operate the opposite function on the result, that is B over A, and it will give us the value of theta. So we actually found out that theta equals to tangents minus 1 B over A. Tangents minus 1 is the opposite function of tangents. Okay. In the next step, we find out the area of sector NON. The area of sector NON. Sector NOM, the angle between its legs is theta plus theta is 2 theta. The angle between the legs of sector NOM is 2 theta. Each leg is equal to A units in its size. It is the radius of this semicircle. And the area of any sector is equal to the angle between his legs, that is 2 theta, over 2 pi, that is 360 degrees in terms of radians, over the area of the circle, that is pi r square, and here r equals to a, so it is pi a square. So in total, the area of sector NOM equals to 2 pi over 2 theta over 2 pi times pi r square. We have pi in the numerator, pi in the denominator, so pi will get cancelled. And found out, and 2, we have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector NOM, it is equal to theta times a square. Then we found out the area of the other sector, sector NLM. The area of sector NLM, the area of this sector equals, first of all, you know that the angle between the legs of sector NLM is equal to pi minus 2 theta, because if you focus on the right angle O and L, this angle equals to theta, this angle equals to 90 degrees of pi over 2. So the missing angle must be equal to pi over 2 minus theta. And because of the fact that the two triangles can move into each other, this angle must be also equal to pi over 2 minus theta. So if we add those two angles together, that is to say pi over 2 minus theta plus pi over 2 minus theta, we get pi minus 2 theta. So the angle between the legs of sector NLM is pi minus 2 theta. That is to say, the area of sector NLM will be equal to the angle between his legs is pi minus 2 theta over 2 pi, that is 360 degrees in terms of radians, times the area of the circle, that is pi r square, and r equals to b, so it is pi b square. So in total, the area of sector NLM equals to pi minus 2 theta over 2 pi times pi b square. We have theta in the numerator and theta in the denominator, so we have pi in the numerator and pi in the denominator, so pi will get cancelled. And then we open the brackets here, pi, and we get that this after we open the brackets, this equation equals to pi b square over 2 minus 2 theta b square over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So in conclusion, the area of sector NLM equals to pi b square over 2 minus OB square. Okay, so found out the areas of the two sectors, and in the next step, if we subtract from the sum of the areas of the two sectors AB, that is the sum of the areas of the two triangles, we'll get the area of the length. That is the general formula for the area of any length. Okay? So the area of sector NOM equals to theta times a square. The area of sector NLM equals to pi b square over 2 minus theta b square. And the area of the two triangles, in total, it is equals to AB, so we have to subtract the area of the two triangles from the area of the sum of the areas of the two sectors. So in conclusion, we found out that the area of the big length equals to this expression. Here we took theta as a current factor, so here from this expression what is left is a squared, and from this expression after we took theta as a current factor from it, what is left is minus b squared. We have also plus pi b squared over 2 minus ab. So in conclusion, we found out that the area of a length equals to, here, theta. Actually, we have already found out that theta equals to tangent minus 1 of b over a. So we substitute theta by tangent minus 1 of b over a. And in conclusion, we found out that the area of a length, it could be any length, is equals to a squared minus b squared. A and b are the radii of the circles that intersect with each other, times tangent minus 1 b over a plus pi b squared over 2 minus ab. So here, actually, in the formula of the area of a length, the only two variables that we have here is the radii of the two circles or semicircles that intersect with each other. Okay, now we will use this new formula in order to find out the area of the big length. So what is the area of the big length? Here, the area of the big length, the area of this big length here, the big length consists of the quarter circle that intersects with this semicircle. In this way, the common area of the semicircle and the quarter circle is this big area. So the radius of the quarter circle A equals to 10 units, and the radius of the semicircle B equals to 5 units. So we know that A equals to 10, B equals to 5, so we put the values of A and B inside this formula, and we found out the area of the big length. Okay, so the area of the big length equals to A squared. A is 10, so A squared is 10 squared, minus B squared. B is 5, so B squared is 5 squared, times tangent minus 1. B is 5, and A is 10, so 5 over 10 is 0.5, plus pi b squared over 2. B is 5, so B squared is 5 squared, that is 25, so it is pi times 25 over 2, minus A times B. A is 10, B is 5, so it is 10 times 5, minus 10 times 5. Okay. So here 10 squared is 100, minus 5 squared is 25. 100 minus 25 is 75, times tangent theta minus 0.5, plus 25 over 2 is 12.5 times pi, minus 5 times 10 is minus 50. So in conclusion, I found out that the area of the big length equals to 75 times minus 1 of 0.5 plus 12.5 pi minus 50 square units. Then I found out the area of this blue length. Actually, the blue length created by the intersection of the two semicircles with each other. Okay? So the area, the radius of each semicircle equals to 5 units. So A will be equal to 5 and B also will be equal to 5 units. Okay, A equals to 5 and B equals to 5. Then we put the values of A and B that are both 5 inside this formula. A is 5, so A squared is 5 squared minus B squared. B is 5, so B squared is 5 squared. So it is 5 squared minus 5 squared. Actually, 5 squared minus 5 squared is 0. 0 times anything is 0. So this expression anyway will be equal to 0 plus 25 pi over 2. And here minus plus pi b squared. B is 5, so b squared is 5 squared. That is to say it is 25 pi over 2 minus ab. A is 5, b is 5, so it is 5 times 5. So it's minus 25. So the area of this big length equals to this expression, and 5 square minus 5 square is 0, so this expression equals to 0. So in conclusion, we found out that the area of the blue lens equals to 25 over 2 is 12.5 pi. So it is the area of the blue lens equals to 12.5 pi minus 25. Then in the last step we subtracted the area of the blue lens, that is 25 pi minus 25, from the area of the big lens, that is 75 minus 1 of 0.5 plus 25 pi minus 50. And here we open the brackets. When you open the brackets, this will become minus 25 pi. And we have minus and minus is plus, so it is minus minus 25 is plus 25. So here we have 12.5 pi minus 12.5 pi is 0. And so those two expressions will get cancelled. And we have minus 50 plus 25 is minus 25. Okay? And in conclusion, we found out that the area of the orange shape PDQ equals to 75 times tangent 1 of 0.5 minus 25. Okay, and here tangent minus 1 of 0.5 is 0.46, and we have to multiply it by 75. When we multiply it by 75, we got 34.77, and 34.77 minus 25 equals to 9.77. So the area of the orange shape equals to 9.77 square units. Here the area of this orange shape DPQ equals to 9.77 square units. We finished with the first method. Then I presented to you the second method. In the second method, use with the same idea that the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so first of all, we found out the area of the blue lens. So the area of the blue lens actually the blue lens was created by the intersections of the two semicircles together. Now we will not use a general formula to find out the area of each length, but we'll use the specific two semicircles that intersect with each other. So we know that the two semicircles that intersect with each other creates the blue area. But we also know that the radius of the two semicircles is equal to 5 units. Okay? So you can write here that the radius is equal to 5 units, and here we have the radius OL that is equal to 5 units. It is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent ML with this semicircle, and whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius MLO. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. Likewise, we have the radius MN that is equal to B, that is equal to 5 units, that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent ON with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent ON will be perpendicular to the radius MN. Tangent ON perpendicular to the radius MN. So if ON is perpendicular to MN, it means that this angle equals to 90 degrees. So then we actually calculated the area of circular segment NL, the green circular segment. We multiply it by 2, and this way we get the area of the blue shape, because those two circular segments are identical, they have the same areas. So if we multiply the area of the first circular segment, the green circular segment, by 2, we get the area of the two circular segments together, that is actually the area of the blue lens. Okay, so here, what is the area? We will find out the area of circular segment NL, the area of the green circular segment NL. The area of the green circular segment NN, it is equal to the area of sector NON. This is sector NON minus triangle NOL. The area of sector NOL minus triangle NOL will give us exactly the area of the circular segment NN. Okay, so here, so the area of this circular segment equals to the area of sector NOL. So here, first of all, we have to find out the angle between the legs of the sector NOL. So if this angle theta, this angle will be also equal to theta, because of the fact that those two right angles can go into each other. Therefore, those two angles will be equal to each other. So if this angle equals to theta, this angle must be also equal to theta. So the angle between the legs of sector NOL is theta plus theta is 2 theta. And the area of sector NOL will be equal to the angle between his legs is 2 theta over 2 pi. 2 theta over no, actually we don't have to do all the calculations here, because here we know that NOL is a quarter circle. A quarter circle with a radius of 5. And we know that the radius of any quarter circle equals to the radius of the circle over 4, because it is a quarter circle. Okay, so the radius, the area of a quarter circle will be a quarter of the area of the circle itself. That is to say, it will be equal to pi r square over 4. A equals to 5, so it will be equal to pi a square over 4 or pi 5 square over 4. So pi 5 square over 4 is actually 25 pi over 4 minus the area of this right triangle LON. So triangle LON is a right triangle, and it is a right triangle that is actually an isosceles triangle because its two sides are equal to each other. So the area of a right triangle equals to the multiplication of the two sides by each other over 2. And O is the base of the triangle times OL is the height of the base over 2. So it is 5 times 5 over 2. Okay, so in conclusion, we found out that the area of circular segment NL equals to pi times 5 square over 4 minus 5 times 5 over 2. And as I already said, the area of the length consists of two circular segments. So if we multiply one circular segment by 2, we get the area of the two circular segments because they are identicals, and the area of the two circular segments equals to the area of the blue length. So here, this is the area of the circular segment. We multiply it by 2 and we get the area of the blue length. So the area of the blue length will be equal to 2 times the area of the circular segment. So it is 2 times 25 5 over 4. And here we have 25 over 2 times 2 is 25. And it is 2 times 25 pi over 4. So here we divide both the numerator and the denominator by 2. 2 over 2 is 1. So 2 will get cancelled. 4 over 2 is 2. So in conclusion, this expression equals to 25 over 2. 25 over 2 is 12.5 pi. So in conclusion, the area of the blue length equals to 12.5 pi minus 25 square units. So we actually found out the area of the blue length. Now our mission is to find out the area of the big length, and when we will subtract from the area of the big length, this area, the area of the blue length, we get exactly the area of the orange shape, that is dpq. Okay, so actually the big length was created by the intersection of the quarter circle with this semicircle. Okay, the intersection of the quarter circle with this semicircle created the big length. This is the big length. So we'll calculate the area of the big length in 2 steps. First of all, we'll calculate the area of the upper circular segment. Then we'll calculate the area of the lower circular segment, and then we'll add them together, and the sum of the 2 circular segments is exactly the area of the big length. Okay, so first of all, we'll find out the area of the upper circular segment NN. What is the area of the upper circular segment? Green circular segment NN. Here it will be equal to the area of sector N sector NLM, the area of this big sector, minus the area of triangle MON. Okay, the area of the green circular segment, upper circular segment MN, equals to the area of sector NOM. This is sector NOM, minus the area of triangle NOM. We know that the legs of the sector, they are equal to 10 units because they are the radii of the quarter circle. If we define angle NOL as theta, then angle LOM must be also equal to theta. Why? Because those two triangles, triangle NOL is congruent to triangle LOM according to side rule. Here, those two sides are equal to each other. They are both equal to 10 units, therefore they are equal to each other. Those two sides are both equal to 5 units, therefore they are equal to each other. And LO is a common side that belongs to both triangles, so it is equal to itself. So those two triangles can go to each other according to side rule. Therefore, if this angle equals to theta, then this angle must be also equal to theta because they are equal to each other. So we actually found out that the angle between the legs of sector NOL is theta plus theta, that is 2 theta. And the area of sector NOL will be equal to the angle between his legs is 2 theta over 2 pi times pi r square, and r equals to 10. Again, the area of the upper sector circular segment NM equals to 2 theta over 2 pi minus pi r square, and r equals to 10, so it is pi 10 squared. We have theta in the numerator, so theta will get cancelled. We have 2 in the numerator, 2 in the denominator, so 2 also will get cancelled. And in conclusion, what is left after we cancelled those two variables? What is left is actually theta times 10 squared. Theta times 10 squared is 100 theta, 100 times theta, minus here the area, minus the area of triangle MNO. And the angle between NO and MO is 2 theta. Each side equals to 10 units, so it is the multiplication of the two sides together times sinus the angle between the two sides, that is 2 theta over 2. So it is 10 times 10 times sinus the angle between the two sides, so that is 2 theta over 2. So here 10 times 10 is 100, and 100 over 2 is 50. So in conclusion, this expression equals to 50 times sinus 2 theta. And in conclusion, the area of the upper circular segment, upper green circular segment MN of the big length equals to 100 times theta minus 50 times sinus 2 theta. Then I copied the right triangle NON in this new page, and we here in this triangle NON, the right triangle, we know that tangent theta equals to NL over ON. Tangent theta equals to NL over ON. NL equals to 5. ON equals to 10, so in conclusion, tangent theta equals to 5 over 10. 5 over 10 is 0.5. So in conclusion, we found out that tangent theta equals to 0.5. Okay? So, what is the value of theta? If you want to find out the value of theta, we have to operate the opposite function of tangents on the result, and this operation will give us the value of theta itself. So here we operated the opposite function of tangents, that is tangents minus 1, on the result, that is 0.5. In this way we got the theta itself, the size of theta itself. So here we found out that theta equals to tangents minus 1, that is the opposite function of tangents, of 0.5. Okay? Then we have, I copied the right triangle LON here, and we implemented the Pythagoras theorem on the right triangle NON. In this way, we found the hypotenuse LO. The hypotenuse LO, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, LO square equals to LN square plus NO square. So LO square equals to LN square, that is 5 square is 25, plus NO square. NO is 10, so NO square is 10 square, that is 100. So in conclusion, LO square equals to 25 plus 100. 25 plus 100 is 125. We took a root out of this equation and found out that the hypotenuse LO equals to the square root of 125. The square root of 125 equals to 25 times 5, so we substituted 125 by 25 times 5, and we took a root out of this equation. The square root of 25 is 5, and inside the root we left only with 5. So in conclusion, we found out that the hypotenuse LO equals to 5 times square root of 5. Okay, so now we have all the sides in this right triangle LON. And according to this equation, we have here 50 times sinus 2 theta. But we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. So it is 2 times sine theta. And here, according to this triangle, in this triangle sinus theta equals to 5 over the hypotenuse, that is 5 over square root of 5. Okay, it is 5 over 5 times square root of 5. While cosine theta, here cosine theta equals to ON over LO, that is to say cosine theta equals to ON, that is 10, over LO, that the hypotenuse is 5 over 5 times square root of 5. So cosine theta in conclusion equals to 10 over 5 times square root of 5. Okay, so substitute sinus theta and cosine theta by their values, and we got this expression. So sinus theta, 2 theta in conclusion equals to this expression. We have 5 in the numerator, 5 in the numerator, so 5 will get cancelled. So in the numerator we have 2 times 10, and the denominator we have square root of 5 times square root of 5 is 5, so it is 5 times 5. Here 10 over 5 is 2, so in the numerator we left only with 2 times 2, and the denominator we left with 5. 2 times 2 is 4, so in conclusion sinus 2 theta equals to 4 fifths. Sinus 2 theta equals to 4 fifths. So in conclusion, we actually found out that sinus 2 theta equals to 4 fifths, while theta itself equals to tangents minus 1 of 0.5. And the area, we have already found out that the area of this circular segment, that is the area of the big length, equals to, that is the part of the area of the big length, equals to 100 times theta minus 50 times sinus 2 theta. But we have already found out that theta equals to tangents minus 1 of 0.5, so we substitute theta by tangents minus 1 of 0.5 minus 50 times sinus theta. We have already found out that sinus 2 theta equals to 4 fifths, so we substituted sinus 2 theta by 4 fifths. And in conclusion, we found out that the area of this circular segment equals to 100 times minus 1 of 0.5 minus 50 times 4 over 5. Okay, so it is 100 times minus 100 times times 1 of 0.5, and here 50 times 4 is 200, and 200 over 5 is 40. So in conclusion, the area of this circular, the upper circular segment equals to 100 times minus 1 of 0.5 minus 40. So we finished to find out the area of the upper circular segment. Now the only thing that is left to do is to find out the area of the lower circular segment. In this way, when we add the two areas together, we get the area of the big lens. Okay, so what is the area of the lower circular segment of the big lens? Here, actually, as I already told you, as I already said, the big lens was created by the intersection of the quarter circle with this semicircle. In this way, created the big lens. Okay, and the radius of the quarter circle is 10 units. So those are the radii of the quarter circle, and the radius of the semicircle equals to 5 units. So those two line segments are the radii of the semicircle. This angle equals to 90 degrees according to rule number 1. If this angle equals to theta, this angle must be also equal to theta, because those two triangles can go into each other. So here we found out this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles, 280 degrees, this angle must be equal to pi over 2 minus theta. For the same reason, this angle must be also equal to pi over 2 minus theta. So the sum of those two angles is pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, I found out that the angle between the legs of sector MNO and OM is equal to pi minus 2 theta, and so the area of the lower circular segment equals to the area of segment MLN minus the area of triangle MLN. The area of the lower segment MN equals to the area of sector MLN minus the area of triangle MLN. The area of triangle sector MLN equals to the angle between its legs is pi minus 2 theta over 2 pi times pi r square, and r equals to 5, so it is pi 5 square. We have theta in the numerator, theta, we have pi in the numerator, pi in the denominator, so pi will get cancelled, and it is minus the area of triangle LMN. The angle between the two sides is pi minus 2 theta, so it is the multiplication of the two sides together, 5 times 5 times sinus the angle between the two sides, that is pi minus 2 theta over 2. Okay, so here we open the brackets here, and we got this is 25 pi over 2 minus 2 theta times 25 over 2. We have 2 in the denominator, so 2 will get cancelled, and 5 times 5 is 25, and sinus pi minus 2 theta equals to sinus 2 theta over 2. So here 25 over 2 is 12.5, so this expression equals to 12.5 pi, and times 25 theta minus We already found out that sinus 2 theta equals to 4/5, so we substitute the sinus 2 theta by 4/5. And we found out that the area of the lower shape, the lower circular segment, equals to 12.5 pi minus 25 and theta, but theta equals to tangents minus 1 of 0.5. Here 25 times 4 is 100 and 100 over 10 is 10. So in conclusion, the area of this lower circular segment equals to 12.5 pi minus 25 minus tangents of tangents minus 1, that is the opposite side of the opposite function of tangents, minus 10. Okay? And the area of the big lens equals to the sum of the areas, the area of the upper circular segment plus the area of the lower circular segment. So we added the two areas together and found out that the area of the big lens equals to this expression, and we already found out that the area of the small lens equals to 12.5 pi minus 25. We subtracted the area of the blue lens from the area of the big lens. Here you can see that if you subtract the area of the blue lens from the area of the big lens, you will get exactly the area of the orange shape. So we subtracted the area of the big lens from the area of the blue lens, or we subtracted the area of the blue lens from the area of the big lens, and we got this expression. And finally found out that the area of the orange shape equals to either 9.77 square units. Okay, thank you very much.